All right, you are welcome again. Today, let's take a look at this question. Solve the differential equation 2x minus y cos xy in bracket dx minus x cos xy dy equal to 0. Please pay attention. This is the question we are asked to solve under differential equation. And if you look at this question very well, you see that it looks like exact equation. But we are not to conclude yet until we test and see if truly is exact. Now let's go. First of all, in our testing whether this equation is exact or not, we have done several videos and several lessons on exact equation. Please, I want you to go through them over and over again for you to understand clearly. Okay? Now let's go. I can remember vividly we said in one of the procedure we say let the side of the equation that is having the x, let's call it a letter m, and then the side that is having the y, let's call it a letter what? N. All right, good. So that means here we're going to say let m equal to 2x minus y cos xy, which is the side that is having the x. Okay, good. Now we have n equal to minus x cos xy. All right, good. Now this our m. We are going to differentiate this m partially with respect to y, and then differentiate our n partially with respect to x. Now, if these two partial derivatives are equal, then we conclude and say that this differential equation is exact. Okay, this our m, when we differentiate it partially with respect to y and our n partially with respect to x, if these two partial derivatives are equal, then we say that the differential equation is exact. Now let's go. In differentiating m partially with respect to y, in this m we have the variable x and y. We can say that m is a function of x and y variables. Okay, so now differentiating m with respect to y partially is saying that every other variable that is not y will regard it as a constant. Okay, good. Now look at it. In this place we have 2x minus y cos xy. You see that 2x, we look at it as if it is what? Is a constant. We regard it as a constant. So the derivative of this constant will give us what? 0. Now we are going to be left with minus y cos xy. Now let's factor out minus 1. So let's put it in outside bracket this way. And then we have y cos xy. Y cos xy. And we are to differentiate partially with respect to y. So in this case, we are going to apply product rule. We are going to apply product rule. Now, we are going to differentiate y, multiply by cos xy, plus we differentiate cos xy, multiply by y. Okay, so when we differentiate y, it's going to give us 1. Then 1 multiply by cos xy. Okay, then we say plus. We differentiate cos xy. What is it going to give us? Now look at it. Differentiating cos xy partially with respect to y. We regard x here as a constant. For instance, look at this. Let's say we have m is equal to cos 3y. If we differentiate this m with respect to y, what will it give you? We are going to have the m all over the y is equal to minus 3 sine 3y. You get right? You see the way we treated 3 as a constant. This is not the full procedure. The full procedure, that is where we say we call this 3y a letter, and then differentiate that one, then bring it back again. That is applying chain rule. Okay, so now the point is this. Let's say, for instance, you have this function m is equal to cos 3y. You see the way you differentiated this cos 3y. You treated this 3 as a constant, right? And then differentiated only y. So this is the same procedure that you use in this place where you have cos xy. You regard the x as a what? As a constant. So differentiating cos xy partially with respect to y is going to give you x sine xy. Then you remember we are applying product rule. So when we differentiate this cos xy, then we multiply it by y. Okay, good. We'll say minus x sine xy multiplied by y. Good. Now let's go. Inside the bracket, we say 1 times cos xy is going to give us xy. Then multiply by minus 1 outside. It's going to give us minus cos xy. And then inside the bracket, we will have plus open bracket minus x sine xy times y. When we multiply inside, it's going to give us minus xy sine xy. Then multiply by minus 1 outside. It's going to give us positive. So here we have cos xy plus xy sine xy. So therefore, we say that the partial derivative of this m with respect to y is equal to xy sine xy minus cos xy. Is that clear? Yes. Now let's go to n. We differentiate n partially with respect to x. Okay, almost the same procedure as what we just did here. So let's go. Let's factor out minus 1 first, and then we differentiate x multiply by cos xy, then differentiate cos xy multiply by x. That is, we apply product rule here. Okay, so when we differentiate x, it's going to give us 1 multiplied by cos xy. Then we say plus, when we differentiate cos xy partially with respect to x. Now look at it. That means we are going to regard y as if it is a constant. Look at it again. Another example. Let's say we have n is equal to cos 3x. And then we are asked to find the derivative of this n with respect to x. What's going to give us? It's going to give us minus 3 sine 3x. Is that true? Yes. I want you to apply chain rule here. Then you are going to see that the derivative of n with respect to x here is going to give you minus 3 sine 3x. All right, good. Using the same procedure here that we have cos xy differentiating partially with respect to x. So we regard y as a constant, and then that means we're going to have minus y sine xy. Then you remember, multiply by x outside. Okay, so here we're going to have minus 1 open bracket 1 times cos xy plus open bracket minus y sine xy multiplied by x. All right, good. Now let's go. Here we have 1 times cos xy is going to give us cos xy, then multiply by minus 1. That is, we are using minus 1 to open the bracket here. So here we're going to have minus cos xy. Then inside the bracket, we have minus xy sine xy. Then multiply by minus 1 outside is going to give us plus xy sine xy. So therefore, the derivative of n partially with respect to x is giving us xy sine xy minus cos xy. Okay, good. Now look at it. We have found the partial derivative of m with respect to y and the partial derivative of n with respect to x, and it happens to give us the same value. Okay, so here we conclude and say that this differential equation is exact equation. All right, good. Now we can go ahead and solve this using the method of exact equation. Okay, so what is the method? Here we are going to say, let there be a function u of x and y such that when you differentiate this function u partially with respect to x, is going to give you m. And when you differentiate this same function u partially with respect to y, is going to give you n. So we are going to find this function u of x comma y. All right, good. Now let's go. We say partial derivative of u with respect to x is going to give us m. But here we already have our m. And then we say that our m is 2x minus y cos xy. Okay, let's call this equation 1. And then again, we say the partial derivative of u with respect to y is equal to n. And then we already have n to be what? Minus x cos xy. Let's also call this equation 2. Okay, now here we can use any of these equations, either equation 1 or equation 2, to find our u. But in this lesson, in this video, I'm going to use the 2 equations, and let's see if we are going to get the same result. Okay, let's start with the first equation using equation 1. Here we have the partial derivative of u with respect to x is equal to 2x minus y cos xy. Okay, we are looking for u itself, but here we have the partial derivative of this u with respect to x. So what we are going to do is we remove this derivative to get our what? Our u is in derivative form. And then for us to remove this derivative form, we integrate. So that means we are going to integrate with respect to x in order to remove the what? The derivative. So we find the integral of the partial derivative of u with respect to x dx equal to the integral of 2x minus y cos xy dx. Okay, now let's go look at it. This is, we split this right hand side into 2, and then you see that we are integrating with respect to x, and in this case now we have minus y, so automatically minus y is a constant, so we take it behind the integral sign. So here we have the integral of 2x dx minus y, the integral of cos xy dx. We are integrating with respect to x, and then we have y in the function. So we regard this y as a what? As a constant. We take it behind the integral sign. Okay, good. Now when we integrate the left hand side, it's going to just strive off the derivative and give us our u. And then in the right hand side, when we integrate 2x with respect to x, is going to give us 2x squared all over 2. Then 2 cancel 2, we have x squared. Okay, then we have minus y. When we integrate cos xy with respect to x, what is going to give us? Just for instance, let's assume that you want to integrate cos 3x dx. You want to integrate cos 3x dx. What is going to give you? Integrating this is going to give you sine 3x all over 3. Hello? It's going to give you what? Sine 3x all over 3. Yes, we have so many videos on integration and differentiation. Please, I want you to watch them if you are finding it a bit difficult. Okay? Now let's go. So here we have the integral of cos xy. So in this case now, we regard our y as a what? As a constant. So when we integrate with respect to x, it's going to give us sine xy all over y. Then plus, in integration, whenever you integrate, you are going to add a constant called c. Okay, but in this case, we are not going to call our constant c. We are going to call our constant t of y. Why? Because the function u we have is a function of x and y, and we are integrating with respect to x regarding y as a constant. So here we say that our constant is y. So here we say t of y. You can call it anything. You can call it p of y. You can call it a of y or anything. So, but in as much y is there as your constant because you are regarding y as a constant. So integrating, so you normally add constant. So you add a constant, we say t of y. All right, good. So here, when we simplify this, we see that in this case we have y minus y multiplied by sine xy all over y. So y we cancel y, okay? And then here we say that u is equal to x squared minus sine xy plus t of y. Okay, yes, let's call this equation 3. All right, good. Now let's go again. We are looking for the function u of x and y. All right, such that when you differentiate this function u partially with respect to x, it's going to give you m that we have, and when you differentiate this same function u partially with respect to y, it's going to give you n. And then we have found this u to be x squared minus sine xy plus t of y, but we don't know our constant t of y. So the only work we have to do now is to find our constant t of y. So if we succeed in getting this t of y, we add it here. That's all. That means we have solved the differential equation we are asked to solve. Okay, so that means the work we have to do now is to find t of y. So what are we going to do? Follow me gradually. We are going to differentiate this u partially with respect to y because we are looking for the constant t of y. So we differentiate it partially with respect to y. Follow me, we are going somewhere. So that means we are going to say the partial derivative of u with respect to y is equal to, in this case, we have x squared. We are talking about partial derivative with respect to y, and then here we have x squared. So we regard x squared as a constant, and when you differentiate a constant, it gives you what? 0. So x squared here is going to give us 0. Now let's go. We have minus sine xy differentiating with respect to y. Okay, it's going to give us minus x cos xy. We have treated something like this before. All right, it's not a new thing. Now let's go. So the partial derivative of this u now with respect to y is giving us minus x cos xy plus, here we have our constant t of y. Because, when we differentiate a constant, it should give you 0, right? Yeah. But here we don't know the value of our constant. So it's not going to give us 0. But it's going to give us a constant in a derivative form. Our constant t of y in a derivative form. So we say t prime of y. All right. Let's call this equation 4. Now, let's see what we have so far. We have equation 1, we have equation 2, we have equation 3, and we have equation 4. Studying these 4 equations carefully, you see that equation 4 and equation 2 looks alike. Equation 4 and equation 2 looks alike. Let's compare these two equations. We say equation 2 say the partial derivative of u with respect to y is equal to minus x cos xy. All right. And then equation 4 says the partial derivative of u with respect to y is equal to minus x cos xy plus t prime of y. Let's compare these two equations together. Comparing the two equations, you see here we have the partial derivative of u with respect to y is this. And then also we have another value for the partial derivative of u with respect to y. Okay, so comparing them, we see that t prime of y is equal to 0. Hello. You see, we have the partial derivative of u with respect to y in the equation 2, and then in equation 4 we also have the partial derivative of u with respect to y. In equation 2 we have minus x cos xy. We also have minus x cos xy in equation 4. And then again, the only thing remaining is t prime of y in equation 4, which is equal to 0 in equation 2. We say that these two equations are equal. Okay, good. So here we say that t prime of y is equal to 0. But you recall that we are actually looking for t of y, not t prime of y. So we take away the derivative of t prime of y by integrating this t prime of y. So when you integrate, it's still going to give you what? 0. All right, good. Now look at this, our function, the u. Our u in equation 3, we say we have x squared minus sine xy plus t of y. And now t of y is 0. So that means we are going to see that our function u of x comma y that we are looking for is x squared minus sine xy. Okay, you remember I told you we are looking for u of x comma y such that the partial derivative of this u with respect to x is going to give us m, and then the partial derivative of this u with respect to y is going to give us n, and then we have x squared minus sine xy. Okay, I want you to differentiate this u partially with respect to x. I assure you it's going to give you m. And when you differentiate partially with respect to y, I also assure you it's going to give you n. All right, good. Now, I promise you to use the two equations and then to see if we're going to obtain the same result. And I just use equation 1. Let's also take the other route, that is using equation 2. So in equation 2, we have the partial derivative of u with respect to y is equal to minus x cos xy. Okay, we are looking for the function u of x comma y such that when you differentiate it partially with respect to x, it gives you m, and when you differentiate partially with respect to y, it gives you n. All right, good. And here we have the partial derivative of u with respect to y equal to minus x cos xy, and we are looking for u. So we are looking for u, and what we have is the derivative form of u. So for us to get the u, we strive off the derivative by integrating the function. So that means we say the integral of the partial derivative of u with respect to y dy is equal to the integral of minus x cos xy dy. So we are integrating with respect to y, and then in this place we are integrating with respect to y in our right hand side. Minus x is a constant, so we take it behind the integral sign. So we have minus x, the integral of cos xy dy. Okay, so let's integrate. When we integrate, we are going to have sine xy all over x. So here x cancel x. So we are going to have minus sine xy plus t of x. Okay, when we integrate, we normally add a constant, and then we say that x is our constant, right? Good. So instead of writing c, we simply write t of x to indicate our constant. Okay, so here we integrated to remove the derivative that we are having in our u, and it gives us the function we are looking for, u equal to minus sine xy plus t of x. Okay, but the only problem we're having now is that we don't know the true value of t of x. So the only work we have to do now is to find the value of t of x. Okay, then we come back to this equation 3 and add it. That's all. Now let's go. For us to find the value of this t of x, what if we differentiate this u partially with respect to x? What are we going to have? So differentiating this function u partially with respect to x, we are going to have minus y cos xy plus t prime of x. Okay, here we have minus sine xy. Differentiating partially with respect to x, we regard y as a what? As a constant. So it's going to give us minus y cos xy. Then plus, on a normal, when we differentiate a constant, it should give us 0, right? But in this case, we have t of x, but we don't know the true value of t of x. As a matter of fact, that is what we want to find. So it will not go, all right? Good. So because we don't know the value and we want to determine the value. So it's going to give us t of x in a derivative form. That's why we say t prime of x, okay? So let's call this equation 4. Now, look at this equation 4 and equation 1. So equation 4 and equation 1, they look alike. As a matter of fact, they are the same. In equation 1, we say the partial derivative of u with respect to x is 2x minus y cos xy. And then in this equation 4, we also say that the partial derivative of u with respect to x is also minus y cos xy plus t prime of x. So these two equations are the same. So therefore, comparing them, we see that t prime of x is equal to 2x. Hello. We see that t prime of x is equal to what? 2x. You remember in equation 3, we are looking for t of x, not t prime of x. So this t of x that we are looking for, when we get it, we are done. But we have t prime of x. That is t of x in a derivative form. So we remove the derivative of my what? Integrating with respect to x. So we say the integral of the t prime of x dx is equal to the integral of 2x dx. So when we integrate, it's going to give us 2x squared all over 2 equal to what? X squared. 2 we cancel 2. So we say that t of x is equal to x squared. Now, look at our equation 3. Our equation 3 said that u is equal to minus sine xy plus t of x. And now we have found t of x to be x squared. Adding it here now, we say that u is equal to x squared minus sine xy. Hello. We say that u is equal to x squared minus sine xy. This is the u of x comma y that we are looking for, such that the partial derivative of this u with respect to x is going to give you m, and the partial derivative of this u with respect to y is going to give you n. All right. So here we follow the first procedure, that is using equation 1, and then we also use equation 2, and we obtained the same result. All right. So this is how to solve ordinary differential equation that is exact. All right. Yes, thank you very much for watching. Please don't forget to like this video, share it, and subscribe if you have not. Thank you very much. Stay blessed.